Hi, welcome back to LeetCode. Today I'm going to discuss LeetCode problem 2530. Maximal score after applying K operation. So the content of this video is, first I will explain the problem statement, then I will see some examples, then I will share the intuition, then we will check the code. Okay. So what is the problem statement? Problem statement: you are given a zero index integer array nums and integer k. You have a starting score of 0. Okay, so in one operation choose an index I such that 0 to I means we can choose any index from 0 to length less than length. Increase your score by nums I and replace nums I with ceiling value of nums I by 3. Okay, return the maximum possible score you can attain after applying exactly k operation. So this operation we can repeat k times, exactly k times. This ceiling function, ceiling of value, is the least integer greater than or equal to value. So ceiling function you already know about. Like if I divide by 10 by 3, the output will be 4. Correct. Ceiling value is the next or nearest integer number. Okay, but if we divide 9 by 3, it will give us 3. Okay, this is the ceiling. Now initially, now go to the actual example, then it will be easy. So first example is our array integer contain only 10 10 10 10 10 5 10, correct, and k is equal to 5. So we can only choose we will only repeat this operation 5 times. So what is the operation? So I will choose the maximum value. So initial score is 0, correct. Now we have to maximize this score. And what is the operation I can do? I will choose any one number from this array and we will add this, that value will be add into the score, and that number from the original array, it will be replaced with x by 3, ceiling value of x by 3, correct. So if I want to maximize the score, then what I have to do? I have to take as large as possible, the x value will be as large as possible. That will actually increase our score. So what I will choose? I will choose what is the number actually larger in this array. So what is the maximum number present in this input array currently? 10. So I'll choose any one of these 10. Okay. So now our current score will be 10, and suppose I have choose this 10, first 10. So it will be replaced with 10 by ceiling of 10 by 3, then 10, then 10, then 10, then 10, correct. So ceiling of 10 by 3, what will actually output will be 4. Then actual, now our original array will be look like 4 10 10 10 10, correct. Now and current score is 10. And what is the operation I have done? K is equal to 1, and here is k is equal to 5. K is equal to 5. So still I have to do 4 operation. Now this is k is equal to, now k is equal to 2. Now what is the largest number present in this array? Now in this modified array, 10 again. Suppose this 10 I have choose. Now a score will be 10 plus 10, correct. Now our array will look like 4 comma 4 again, then 10 10 10, correct. Now k is equal to 3. Now what is the largest number present in this array, this modified array updated? Again 10, this 10 suppose. So our score will be first of all modified with 10 plus 10 plus 10, and array will be modified to 4 again, then 10 10. Now for the fourth time, whenever we're calling this function operation, so I'll choose what is the maximum number present in this array. Again 10, suppose this 10. Now our score will be 10 plus 10 plus 10 plus 10, and array will be modified to 4 comma 4 comma 4 comma 10. Now still I can do one operation. So k is equal to 5. So the score will be what? What is the maximum value here? Maximum is 10 again. So ultimately this value will be 10 plus 10 plus 10, and array will be modified to 4 comma 4 comma 4. Now actually our k is equal to 5, so I have actually achieved 5 operation. So our score will be ultimately, this is our answer, 15. So this will be our answer, correct? 50 will be our answer for this example. So you can check what is the answer. Answer is 50. Okay, this is for k is equal to 5. Suppose they have actually input change and the k is equal to suppose 6. Suppose now k is equal to 6. Now what actually then what will be the answer currently? So what is the maximum value from this array now? 4. Any one of I can choose any one of these 4. So the score will be currently 50 plus 4, and array will be modified to 4 by 3, this ceiling value, and 4 comma 4 comma 4, correct? And 4 comma 4 by 3, it will be actually 2 4 4 4, correct? So if our k is equal to 6, then our answer will be 54. It's clear what is the how it is working and how it is getting the expected output, correct? So what is the intuition? How can I actually solve this problem? So first of all, we will have an array of numbers, and we will have some k. So I will choose what is the maximum number for this current array, correct? Suppose x is the maximum number. Now score will be increased by x, correct? And our array will be modified to x by 3 of ceiling. Okay, now, and we have all the elements, rest of the elements that actually already present previously also. Now I'll choose now the modified array, which is the maximum number. If we have this, still we can actually call this operation again. If k is like, what is the number? K is still greater than 1. So I will again call this function that will actually give us the what is the maximum value present in this modified array, whatever the array or collection of numbers. What is the maximum number that will actually return? So, correct. And again I will add that maximum value into our score, and I will pop that from our array, that actual number x, because x will be popped back, and what will be push back will be ceiling of x by 3, correct? It will be pushed back into the collection of number. Here actually you can check, we initially all have 10 10 10 10 10. So this is our collection of number. So I will call any helper function helper. This will return what is the maximum number present currently in this array. Okay, and this will return suppose 10. So what will do, I will add this into our score. Okay, and this will be actually replaced, means whatever the 10 is present, that will be replaced with ceiling value of 10 by 3 and 10 10 10, correct? It will be now, this will be the modified array. So you can think out that we are actually trying to find what is the maximum value every time, correct? And it will also will be popped from the array, and again it will push into the array, which is a modified number, correct? So you can think about, we can use priority queue here. How? Maximum heap. So what actually priority queue actually do? So it will actually store the maximum number at the top, correct? X, Y, Z in this way. So whenever I call this function, so this priority queue, I will check, it will return what is the maximum value present in this. Okay, so it will return x. Okay, so this will be our score. So it will be add into our score. X will be added into a score, and what I will do, I will just pop this x from the priority queue, correct? And what I have to push back again? I will push ceiling of x by 3, ceiling value of x by 3, correct? Now suppose y is the maximum value, z is again, and x by 3. This will be our priority queue now. Now next time whenever I call what is the maximum value, this will return actually y, or any one of the x by 3 also possible, correct? So we can use priority queue here. The data structure, it will actually return the maximum value every time present in this array, correct? Just now go to actually code. So code actually is simply easy. So this actually you can check our expected return type is long, so that's why I have taken an answer that is score actually. So this data type is long, and we have taken a priority queue, integer type, name is priority queue. So first of all, I'm iterating the input integer array nums. I will insert all the numbers. So suppose 10 10 10, correct, 5 10 actually I have in the nums. So I'll just create a priority queue for this number, all these 5 numbers. Now what I have to do, I can call this helper function k times. So that's like I is 0, I less than k, I plus plus k times I'm calling this function. So what actually this will do, so I'll check what is the maximum value present in this array. So priority queue will, at the top it will contain the maximum value because it is a max heap. So I'll check what is the maximum value present in the top, priority queue dot top. It will return the maximum value 10, and I will pop this because this will be replaced. So I'll pop this. Now this temp will be our current one of the score. So I'll add this into our answer. Answer or means score. So score will be initially 0 0 plus 10 now. And what will be replaced in the priority queue, replaced with ceiling value of 10 by 3, ceiling value 10 by 3. I am inserting this into the priority queue again, priority queue dot push the ceiling value of 10 by 3 or 10 by 3, whatever the value present currently. In this section I will call this function k times because I can do only exactly k times this operation, and ultimately return the answer. It is clear? If you any doubt, any suggestion, you can comment on that. I will reply. And if you're not yet subscribed, please subscribe to follow the code or related problems solution related to coding. Okay. Now what is the time velocity of this? So I'm using priority queue here. So you can check here. Actually, we are calling this priority queue n times because suppose our length of the nums array is n. So I'm calling this priority queue n times. We're inserting n numbers into the priority queue. So here actually time velocity will be n log n because each time to insert the time velocity will be log n, and n times we are calling this because n numbers can be present. So it will be actually n log n. Okay, this is for inserting. Now k times we are calling this operation. We can do the operation. So we are actually popping, and first of all we are popping to get the maximum value, and again we're what is the pushing? Pushing actually is 10 ceiling value of 10 by 3 or whatever the number value actually have by 3. Correct. So this will be called k times, and hold concept because n number are present in the priority queue. So time should be log n to check what or rearranging in this way. So that's why it will take log n, and we are calling this rearranging or helper function k times. So that's why k log n ultimately. Got it? So ultimately this is a way time velocity big of n log n plus k log n. And now what is the space velocity of this algorithm? Space velocity is we are using a priority queue here. So here actually n maximum n number are present, can be present in the priority queue. Okay, so space velocity big of n. It is clear? Please subscribe the channel if you not subscribed. Please like the video also if you not yet, if you like the explanation. Okay, thank you.